All the protocols we will discuss in today's morning session. And in the afternoon session, we are going to introduce one or two clouds, depending on the time permits. I will introduce one or two more clouds so that I will complete the life cycle of IoT. So that starting from the sensors and also will able to send the values to the cloud. Okay. So good morning, everyone. So before going to that, let me share my screen over here. I hope my voice is clear.
Yes, sir. Voice is clear, sir.
Okay, thank you. So let me share my screen. Okay, so now you are able to see my screen over here. Let me stop. Right, sure. Alright. So today's topic here it is IoT hardware platforms, standards and protocols. So before going to discuss about this, uh, I will discuss that what is the structure of that IoT. Yesterday we discussed about that, and where these protocols will comes into picture in that particular structure. So that first overall structure we'll discuss, and then we'll go for the this topic like hardware protocols, standards, and the protocols. So let's take a small pen here. So yesterday we have seen that there are uh, four different stages. One is first stage is that we have to have a sensors over here, okay, and the second stage is that we are going to have a microcontroller over here, okay, and the third stage we are going to have a gateway. So yesterday I told you that gateway is maybe sometimes inside the microcontroller. Okay, it will be act like a, for example, Raspberry Pi is a mini gateway. So it will be act like a gateway so that it will have internal Wi-Fi, Ethernet port, and everything is available in the inside the controller. So in that case, it will be act like a gateway internally. But whenever we are going for the IoT practical cases, so sometimes what happens here, microcontroller will not have internal Wi-Fi and all these things. So in that particular case, we'll go for the routers or gateways. So like generally Cisco will provide the gateways. Most of the gateways are provided by the Cisco company. So generally we use the Cisco gateways to connect your microcontroller to the cloud part. So here cloud comes into picture. So at this particular four different stages, we have to discuss about the few protocols over here. So the first protocols are hardware protocols. So that means how you are connecting your sensor to the microcontroller. Of how many different ways you are connecting your sensor to the microcontroller. So here in this particular case, so we are going to use four different protocols over here. One is UART. Generally, you might have heard about this like universal asynchronous and receiver and transmitter. So UART protocol. Okay, and we have something called I2C protocol, and we have something called SPI protocol, and we have also something called GPIO. Yesterday we have seen that we connected a few sensors using GPIO. Like yesterday we have seen that DHT11, we have seen the LDR sensor, we have seen the ultrasonic sensor. So these are all GPIO kind of thing. So yesterday we have seen how to connect a GPIO sensors. But other than these GPIO sensors, there are a lot of other sensors which are available in the form of I2C. So these pins are different. Like GPIO, we have only data pins. Like yesterday, like in the LDR, we have a data pin. In the ultrasonic, we have echo and trigger pins. Okay, in the DST11 we have a data pin. So something like that. Those are all GPIO pins. Similarly, other sensors which are having a form of I2C, which are having some form of SPI. So today we'll see the examples of this I2C, SPI, uh, UART also, if possible, UART sensors and all these things. So, what are all these called as hardware protocols? So, this is our first topic. What are the different hardware protocols? And then the second stage, so whenever this gateway is inside the microcontroller, that is fine. There is no need of connecting any external something gateways or something other. But there are some situations where gateway is not able to install. Why? Because to install the gateway we require a lot of power and a lot of equipment, internet connection, and all these things are required. But there are some remote locations where we are not able to install the gateways. So in such situation, we can simply install only microcontrollers. Okay, and how this sensors information transfer to gateway. So there are some wireless devices connected to a microcontroller. Those are your Bluetooth. Okay, this is very well known. Everyone know, most of the people knows about this Bluetooth. And there are something called Zigbee. Okay, there is something called Zigbee, and also there is something called LoRa. You might have heard about, or you may not have heard about this. We will discuss about all these things slowly one after the other. Okay, there are something called LoRa, and also there are something called SIGFOX. So these are all called wireless protocols. So when we'll use these wireless protocols, when we want to send the data wirelessly, where we are not able to install the gateways and all. So in that case, we can send the sensors data wirelessly to the gateway. So of course, here in the gateway, again we are going to have a small kind of microcontroller inside the gateway. Okay. So anyhow, this data is wirelessly transferred to the gateway, so that this gateway will receive the Bluetooth information, will receive the LoRa information, will receive the Zigbee information. So this gateway may have a different kind of communications. Gateways must be enabled with the Bluetooth, must be enabled with the LoRa, must be enabled with the Zigbee. So depending on your situation, for example, if you are using the LoRa for your communication, here you have to use the LoRa gateway. Okay, if you are using a Zigbee, then you have to use the Zigbee gateway over here. Okay, so like that, whenever there is a situation where we are not able to install the gateways, we'll use some wireless protocols to transfer the sensor data. So this is our second topic. The first topic is hardware protocols, and second topic we have to discuss about the wireless protocols. This is the second stage of protocols. Okay, finally we reach the sensor data. Everything is reached to the gateway. Then how we'll communicate this data to the cloud? So to communicate this data to the cloud, again we are going to have few protocols. One is called MQTT, very famous protocol for the IoT, especially for IoT. This is a very important protocol that everyone has to know this terminology. What is MQTT and how to connect to the MQTT. See, whenever you want to work with the IoT or next whatever that blockchain and all, so you should have to know minimum protocols that you have to work on that. So here MQTT is the one protocol you have to know. The second one is the HTTP. Okay, HTTP. I think this is a very general protocol, like very traditional protocol. So we are using from a long time. Okay, and there is one more called as OAP. Okay, so we will see all these protocols. What are all these called? These are all called as a application protocols. So what are these are all called as application protocols. So our target is very clear today. Today I want to discuss about all these protocols. One is at the hardware stage, at the sensors and the controller stage, we have to require how we can connect the sensors to the controller through hardware protocols. So these are the four hardware protocols, and how we are sending the information wirelessly to the gateway. That is called nothing but wireless protocols, and how you are sending the information from the gateway to the cloud. These are called application protocols. So these are the three different kinds of things we'll concentrate today in the these 2 hours session. Okay, I think agenda is clear over here. So let's move on to the topic. Okay. So already you have seen that yesterday I told you that there are some few hardware platforms are there. So I want to introduce just in a 5 minutes because already yesterday we have seen that Raspberry Pi 4 is one of the uh, hardware hardware which is going to be used. So yesterday we already discussed about all these things. Okay, this is the one protocol of see all these are IoT hardware boards. IoT in the sense it should have Wi-Fi internally. This is our processor and this is your RAM here and this is your Wi-Fi chip over here and this is your some Bluetooth chip here. So like that, sorry, not this one. This one is the Wi-Fi chip. Here it is. Okay. Okay, so this something like that. Uh, Everything is going to be involved into a single place. Then it is called as a IoT hardware board. So this is one of the popular IoT hardware board. So no need to discuss about this. Yesterday we have already seen about all these things. The next popular board for IoT here it is the Arduino Uno. The people who wants to start their IoT course and all these things, and they don't want to learn much deeper into that particular thing, then your Arduino Uno is the best way to communicate with the different sensors because Arduino Uno is the one of the popular board which supports many number of sensors. So if you believe or not that Raspberry Pi is also not support that many sensors where Arduino is supporting. The people still, most of the sensors are still giving the accurate results using the Arduino instead of using the Raspberry Pi. But of course, whenever coming to the processing capabilities and all, Raspberry Pi is the best. Okay? This is will support the more number of sensors. So this Arduino is going to have a 0 to 13. So totally these are the 14 digital pins. 14 digital pins available here, and there are 6 analog pins available over here. So yesterday we have seen that there are digital sensors and analog sensors are there. So directly we are having all analog pins over here and digital pins over here. But whereas in your Raspberry Pi, all are digital pins only. There is no analog pins. Then you can ask immediate a question for how to connect the analog sensors over here. So if you want to connect analog sensors, you have to use some ADC circuit over here. Generally, I'm using MCP 3008. There is something called MCP 3008. This is my ADC. So you have to connect your all analog sensors over here, and this MCP is connected to the Raspberry Pi. Okay. So these are the so if you want to read something from the analog sensors, you may analog sensors like gas sensor, like any other sensors like soil moisture sensor. So different sensors are different analog types of sensors are available, like analog temperature sensor, analog so many things are there. So if you want to connect any analog sensor, definitely you have to use an ADC. What is ADC here? Analog to digital converter. So Raspberry Pi doesn't have any analog pins internally. We have to use external ADC to connect analog sensors. But your Arduino is having internal analog pins directly available. There is no need to use any external ADC to connect your analog sensor. So that is the one of the biggest advantage of Arduino. So there is no need of connecting any external ADC for the Arduino. So yesterday I told you that this is 16 megahertz operating frequency of Arduino is 16 megahertz, whereas Raspberry Pi is 1.5 gigahertz. So just see the difference here, how much difference it is. It is in megahertz, it is in gigahertz. Okay. And there is no internal Wi-Fi, there is no internal Bluetooth, everything we have to connect externally. There is no internal Bluetooth and Wi-Fi are not available in the Arduino. We have to connect everything externally. And whereas our RAM is 8 GB, for Raspberry Pi RAM is 8 gigabytes, but for Arduino it is only 2 kilobytes. Very new RAM, very small RAM. Okay? So, so that's the design of Arduino. But thing is that Arduino will support so many number of sensors. Most probably in the IoT, we have to give a utmost preference for the sensors only, right? Because Sensors are the ultimate things where it can sense the things and all these things. So our information in the IoT, the main information is coming from the sensors only. So whenever you have a utmost importance for the sensors, definitely you have to go for the Arduino Uno. But whenever you have a utmost importance for the speed and execution speed and processing speed, then you have to go for the Raspberry Pi. And this is another board which is combines the Wi-Fi and Arduino. This is your Wi-Fi, okay, Wi-Fi and Arduino. So combination of Wi-Fi and Arduino will come under as a node MCU. So most of the people who are working with the students, especially students, will prefer this board. Why? Because it is tiny, very tiny, and also Wi-Fi is available internally. No need to connect external Wi-Fi for like same like Arduino. So here we have to connect the external Wi-Fi for this particular Arduino Uno. But whenever you are using the node MCU, no need to connect any external Wi-Fi. So because internally the Wi-Fi is available. So that is the one advantage of node MCU. But again, coming to the processing speed and all, it is little bit increased from the Arduino, that is 80 megahertz, and RAM is 128 kilobytes, whereas for Arduino it is 2 kilobytes for ESP8266. So that is also called as node MCU. So for this particular thing, the memory is increased to 128 kilohertz, and there is a internal Wi-Fi is available. These are the different features of different boards. Of course, there are some commercial boards are available. These are all three are open source boards. So this Raspberry Pi is a open source board. Open source means it's not like free, but there is no copyright issues. So if you want to develop any applications using Raspberry Pi 4, you can develop because there are no restrictions like you should not use this, you should not use that, something like that. Because this is the open source, anyone can work on any application on this particular Raspberry Pi 4. There is no restrictions on here. So the first three like Raspberry Pi 4, Arduino Uno, Node MCU, all the three are open source boards. There are some commercial boards are there like ARM Embed. ARM is using the some embedded boards. Of course, this is also not commercial, but this is very typical to work like it is going to work on the embedded C language. So it's very, of course, in the especially people from Europe and United States, US and Europe, those people will give the training for the students on this board because even I taught few programs and for the students earlier on this particular board. Some US students, I taught the experiments on this particular ARM embedded board. It's a very comfortable board, but at the same time, very difficult to write the program using the embedded C. Whereas your Raspberry Pi is very easy to write the program because that is depends on the Python. Python is the easiest language compared to the embedded C or Java, whatever it is. If compared to any other language, Python is the very easiest language. Okay, so here this ARM embed is going to be used in some places. Okay, so where if anyone wants to go through it, they can go through these particular things. Okay, next. So again, it is having a 256 KB RAM and 120 megahertz, same like your Node MCU. Yes, Node MCU is also, sorry, Node MCU is 80 megahertz, so whereas your ARM embedded is a 120 megahertz. So it's a little bit advanced version of your Node MCU. Again, it is having internal Bluetooth, it is having internet port so that we can connect the internet directly, but there is no internal Wi-Fi. Internal Wi-Fi is not available, but internet is available. So that is nothing but we can connect the RJ45, but internet cable is there now. So we can connect the broadband cable to this to get the internet connection. Okay. So like that, why I'm discussing all these things means whenever you are working with the different boards, they have different features. So you should have to know what are the different features that are available over here. This is one more board given by the Intel because most of the people coming from the background of electronics or computer science. They may have seen the 8051 and 8086. Those are there. So these are given by Philips and Intel. So okay, so this Intel is later on now. It is internally giving the small microcontrollers, but later on it is developed the IoT controller. So this Intel also provide the Edison board. The Edison is the name of the IoT board, which is provided by the Intel company. Okay, so this is also one of the IoT board. Again, it is having 1 GB RAM. So you can see here, 500 megahertz operating frequency. It is almost nearer to Raspberry Pi 2. In the Raspberry Pi 2, earlier version of the Raspberry Pi, not even two, first version. First version of the Raspberry Pi is having same like this, 1 GB RAM, 500 megahertz of clock frequency, and internal Bluetooth, internal Wi-Fi. Everything is available. And here it is having Atom processor. Generally, you know that Intel people are using the Atom processor. So these are the different other popular boards. If you are come across like ESP32 is nowadays most of the people are using the ESP32 because this is having a little bit better clock speed, and internal Bluetooth is available, internal Wi-Fi is available, and very tiny in size, and good operating frequency, not bad, not worst. Like it is having a good operating frequency and all these things. So for your IoT applications, it is going to be suitable best whenever you going for the practical purposes. Okay. So an Arduino Nano is very tiny in size. Whenever you want to go for only one or two sensors, I don't want to connect many number of sensors. I want to connect only one or two sensors, and then your Arduino Nano is the best choice. So like that, depending on your situation, what applications you are using, and depending on your situation, you can choose any of these boards. And some people who want to work on the Arduino Uno, but don't want to connect any external Wi-Fi, then they can go by the Uno plus Wi-Fi board. This is called Uno plus Wi-Fi board. So Uno is available here. This is your Arduino Uno, and similarly there is a Wi-Fi is available over here, so that you no need to connect any external Wi-Fi over here. So this is called Uno plus Wi-Fi board. And there are also very small and very tiny device of Wi-Fi is MKR Wi-Fi 1010. So uh, the people who wants to work on the Bluetooth and Wi-Fi, so then they can prefer this MKR Wi-Fi 1010. This is battery operated. Here we have a special port to connect the battery here. You observe this. This is the battery port is available, so that directly you can connect some 3.3 volts battery like with some power. So that what happens here, this device can be works for the 5 years to 10 years on the battery itself. So that is also one of the advantage. Like see, whenever you want to install some device, every time changing the power is also not good. So this kind of devices we have to choose where power requirement is very important for us. So in that case, like different situations, we have to choose the different controller depending on our application, what we are doing. Okay? So this is my intention of giving the different hardware boards over here. So this is the final board that yesterday we have seen that this is a board which is developed by the Exchange Solutions Private Limited. Especially this board is developed for the training to the students, because whenever we are getting all these components individually and trying to connect with the individual GPIO wires and all these things, at that time we are facing a lot of issues in loose connection and in connecting the breadboard and all these things. And while especially while training the hundreds of students, whenever we are training the see one or two students means okay, we can sit with them and we can ask them to connect this, connect that, and so that we can easily monitor them. But there is hundreds of students, like 50 members of students, hundreds of people are there. There is that is not possible to go each and every student and monitor them individually. So in that particular case, we designed a board in such a way that it is very easy to connect and all these things. And at the same time, we can explain all the concepts over here, because we are not connecting directly here. We are using some wire. So while we are connecting the wire, we can explain what this wire is connected for. What is the VCC, what is ground, what is data, where it is connected, and how it is connected to the GPIO pins here, 40 GPIO pins, how it is connected. And all these things we can explain to a student before they are doing the program and all these things. So once they connected, they can write their own program on the Raspberry Pi and they can see the result. So whenever you are training in bulk, I suggest that this board is very useful for you without any uh, like much risk, so that you can do all the basic programs like LED, starting from the LEDs, switches. Okay, you have all the stepper motor here. The stepper motor is there. The relay is there. We can connect the DC motors. We can connect the AC bulbs. Okay, and here we have a LCD display. We have 7 segment display. So something like that. A lot of things are provided on the single board, so that no need to go for any particular. So especially whenever you are designing a IoT course for the students, so this board is very useful to perform the experiments on the IoT lab. Okay, so especially we design this board for that particular purpose. Okay, right. Before going into the sensors and actuators, so let me give 1 minute time. So, is there any questions from the audience regarding these boards and all? So, earlier you have worked with any other boards, or you faced any other problems, or you have any doubt regarding the earlier boards and all? So you can post your question over here if you have any uh, doubts regarding your earlier boards. Yes, I want to take a 1 minute gap here so that you can think about any other things and you can ask your doubts over here. So for every 20-25 minutes, I will take a break of 2 minutes, because continuously if I end like this, very difficult for the people to digest. So I'm clearly explaining line by line like what we are doing at every stage. So up to now what we have seen, up to now we have seen only the hardware, uh, but controllers, all the different types of controllers that are available. Okay. Okay, right. If there are any other questions, if there are no questions, then we will move back to the next topic. That is, we are going to see what sensors and actuators. What are the different sensors and actuators which are available in the market? So yesterday we have seen only three sensors like DST11, the one sensor we have seen, and we have seen LDR, and we have seen an ultrasonic sensor. So other than that three sensors, there are some other sensors are available. So let's discuss about all those sensors and actuators, okay, and then we'll go for the other ones. Um, Let me move back to this. Okay. So next topic is here is sensors and actuators. So let's first of all, what is the difference between sensor and actuator? Sensor is always take the input from the environment. Sensor means it is always take the input from the environment. For example, here it is try to measure the temperature, try to measure the humidity, try to measure the speed of the vehicle, try to measure the light intensity of the environment, try to measure the pressure of the environment. Okay, so try to measure the distance of the object. So like that, whatever it is giving, yeah, it is trying to measure something from the outside. So that is nothing but your sensor. Maybe measuring all these parameters, different parameters it is going to be measured. So what generally sensor will do, whatever the physical parameters, these are all called as physical or environment parameters. Pressure, temperature, humidity, the speed, light intensity, all these are some physical parameters. Some we can call it as acoustic parameters. So all these parameters will be converted into electrical signal. That is nothing but it will convert into a voltage or current. Simply speaking, that a sensor is a device which converts the physical parameters into electrical parameters. That is, it will convert that into either voltage or either current. Okay. Of course, after this voltage and current, we have here it is a digital kind of output and analog kind of output. Again, that is a different case. If it is a digital means that voltage will be converted into digital form, or otherwise current will be converted into digital form. Otherwise, we'll take directly into the analog form. So whatever it is, digital analog is a depending on the what type kind of output we are getting. For digital, generally we get a 0 or 1 output, 0 or 1. Okay, it is in the form of binary. Okay, so whereas our analog means it is a quantity. For example, temperature is the quantity. It's not a 0 or 1. It's not a true false kind of thing. The LDR is a digital sensor. Why? Because it is true false, either light present or light absent. So it will give output of a true or false, whether the light is there or not there. Okay, that is called digital. Whereas analog means it has to measure the quantity. Like for example here, gas sensor. What is the amount of gas available in the environment? What is the amount of moisture available in the water? So like that, amount of that particular input will be measured in the form of analog sensors. Okay. So the sensors may be again divided into analog and digital depending on the output. And then opposite side, actuators. What are actuators here? Actuators means output devices. These are all input devices. Sensor, all the sensors are inputs. Always remember that sensor means definitely it should be an input. Okay. Whenever it is output means it is not sensor, it is actuator. For example, LED is not sensor, LED is a actuator. Okay. A stepper motor is not a sensor, stepper motor is a actuator. And DC motor is an actuator. And relay is a actuator. Okay, these are all not the sensors. Relay, motors, LEDs, these are all not sensors. Again, switch is a sensor because switch is a input device. Switch is not a actuator. Switch is a it's a sensor. So something like that. You have to know the difference between a input and output. So all the sensors are generally input devices, whereas all the actuators are output devices, like your LED display, like LCD display, 7-segment display, your joystick. Sorry, not joystick. Joystick is input. Okay. So motors, all the motors, stepper motor, DC motor, servo motor. So all the motors are output devices. Okay. So this is a small block diagram. I don't want to discuss here. So these are the different sensors which are available in a GRU form. So GRU sensors means these are some standard sensors. So whenever you want to avoid the glimpses, like whenever you want to avoid the hecticness in the sensors and all, then we suggest to go through the GRU sensors. So these are the little bit uh, class, class, uh, classy sensors, so which is going to be given a accurate output for you. Okay, so these are all like digital light sensor, digital temperature and humidity sensor. Okay, and this is not light sensor, this is temperature sensor. No, no, the LDR is there, it is a light sensor. LDR is there, it is a light sensor. And this is your DST11 yesterday we have seen that. So this is the DST, GRU DST11 sensor. This is barometer. Barometer means it will measure the pressure in the air. This is the air quality sensor. Okay, this is some air quality sensor. And this is temperature sensor, gas sensor. Okay, like that we have a different kind of sensors available in the form of GRU. What is the common point available in this? Everything is having a connector over here. So this is called GRU connector. So this is having connector. For normal sensors, these connectors are not available. We'll have only 4 pins like this. 4 single female pins are available, or otherwise male pins are available. Okay, but here it is not pins; it is a connector. So that is the specialty of a GRU. It will whether the pin is having 3 pins or 4 pins is useful, but everything will be comes with a standard connection. So this is some standard connections that is a groove sensor is having. So these are the normal sensors like other than the groove sensors. So this first one is IR temperature sensor. How many of you know about this IR temperature sensor? So this is generally used to measure your body temperature without touching, like contactless. So after Corona, this Corona in the Corona period, we used all the gun kind of sensors. Like everyone is trying to find your body temperature without touching your body. So that is internal inside that particular those equipment. We use the sensor called IR temperature sensor. So if you search for in the Google, you can find out this. You can easily connect this to the Arduino or Raspberry Pi. So whenever you want to connect to Arduino Raspberry Pi, you can uh, buy this and you can make our own body temperature sensor. Okay. The second one here it is the pulse oximeter. The second one here it is a pulse oximeter. So this is the place where if you put your finger on this particular place, it will calculate your pulse, like BP. So like it will gives you the blood pressure of your body particularly. Okay. So whenever you place your finger on this particular place, then it will calculate the pulse of the body. So this is also generally we use clip kind of thing. Internally inside the clip, we are using this sensor only. Otherwise, generally, if you observe the watches, so the watches are having internally this particular sensor. Okay, so whenever you wear your watch to the hand, this particular sensor place will be always touched to the hand, and it will always calculate your body pulse rate. So how whether you are in a good condition or bad condition, so we can easily know about by calculating your pulse rate. Okay, so these are the two very important for healthcare kind of. And there is something called PIR sensor. This is a wall mount. Generally nowadays, most of the latest buildings are having this wall mount PIR sensors. These sensors, whenever you fit this sensor into the wall of the particular room, so whenever any person enters inside the room, this PIR sensor will recognize the persons. So according to that particular thing, it will switch on the lights, it will switch on the fans. So everything, these lights and fans, everything will be automated based on this PIR sensor. Okay. So like that, we have seal mount PIR sensor, and yesterday we have seen that this is our digital like distance monitoring system. So it will calculate the object distance from sensor to the object. And there is something called fire detection sensor. So this is a one different case of fire detection sensor, and this is one different case of a fire detection sensor. So this will detect the fire here. This is detect in the form of IR, and this will infrared. Like it will also here this will project some infrared rays over here, and whenever there is a fire is available, so it will reflect a different types of waves over here, so that it can easily recognize that the fire is happened inside the room. Okay. And there is something called IR sensor. Again, this is generally used to calculate the object detection, like whether any object is available or not. Exactly, not exactly the distance and all, but it will generally use it to whether object is there or not. Okay, so generally it is having very less distances, whereas here it is having up to 4 meters, but it is this sensor will calculate up to centimeters only, not completely uh, much distances. But what is the difference? Main difference between this IR sensor and ultrasonic sensor? This because both are used to detect the object, but IR sensor can detect the objects in the fog environment. Like whenever the environment is not clear, like generally in the winter season, especially in the areas of north, so much of fog is available on the outside environment. In such situations, if you want to detect any objects in the fog environment also, this particular sensor will be acts very very accurately, whereas these particular sound sensors are not penetrating to the fog. So when there is a fog situation, this ultrasonic sensor is not able to detect the objects properly. Of course, depending on the thickness of the fog, so if the fog is not much thicker, then ultrasonic sensor will able to detect the objects and all. But whenever the fog is a little bit very heavy fog is there, then it's very difficult to for the ultrasonic sensor to detect the objects. And there is something called purity of water, turbidity sensor. So it will find out that generally it is not used for the pure water. This is generally used for the lakes. So whenever you are in a lake, so whether that lake water is able to drink or not, how much fluoride inside that, or how much particles, like it is very clean or so much of dust particles are inside the lake and all these things. So turbidity will not find any uh, like inside the water. It will not find out any qualities of the inside the water. It is outside the water. Like uh, whenever you put the sensor into the water, it will find out that whether the water is very clean or having so much of dust inside the water. So dust, it will find out the dust particles, not the uh, like pH and pH values and all these things are different. Okay, and this is find out only purity, water, how much pure the water is, lake water, whether the lake water is pure to drink or not. So something like that. It will find out the turbidity of the water. Okay. And this is soil moisture. It will always measure the moisture content in the soil. So generally it is used for a plant monitoring system. So whenever you have any uh, plants, like something like that, if you want to water the plants automatically, so then we'll use this soil moisture sensor. So this is some advanced version of the same soil moisture sensor. Generally this is used for the crops. So generally this is used for the crops. Okay, and this is used for the plants, small plants. So whenever you have a small plants, we use this one, and whenever we have a crops and all these things, we use this one. Of course, this is available in different sizes. Sometimes it may be available in the 2 meters long, 4 meters long, something like that. Long, long length sensors are available. Okay, and also one of the very very nice sensor here is pH sensor. It will calculate the pH quantity of the water. So that means whether we are drinking right water or not. So for example, generally we are drinking the tap water. So before going to drink the tap water, you can measure the pH quantity of the water, whether that particular water is harmful to our body or not. So, but because that we can't able to see, we have to measure it, because we can't by simply seeing the water we can't say that this is a bad pH, this is a good pH, something like that. We have to measure internally inside the water whether this is a pure pH or not. So your distilled water is having a pH value of 7, and remaining other sensors are having, so remaining other water is having in between 6 to 8. Okay, so of course, getting the pH 7 water is very very difficult, because that is very very pure water. It should be very pure water. But nowadays, even though distilled water also not that much pure. Sorry, not distilled water. Like in our homes, we use the water cans. So that water also not that much pure. Like it should be 6.5 or otherwise 7.5, something like that. Okay. So these are different sensors that we have, and these are all actuators. So these are all inputs. So whatever we discussed up to here, this one and this one, these are all input sensors, and these are all outputs. LEDs, okay, LCDs, budger, 5 volts relay, servo motor, gear motors, water pump motors, stepper motors. This is electric valve. How many of you know that this one? This is used inside your washing machine, coffee machine, inside your washing machine. These are See, whenever you can easily observe that whenever your washing machine comes to repair, the person will first comes and check the electric valve, whether this valve is working fine or not. Because this is the only part generally will damage inside the washing machine. So immediately they will take this out and they will replace the electric valve. And remember that if you buy it in the market, its cost is 350 rupees. But if the person will take at least 650 to 800 rupees, the service charge and all, I don't because I faced it really. So even I rejected that and I bought my own sensor and I fixed inside the washing machine. Okay, but anyhow, this is the electric valve which is used to control the water flow. When it has to stop the water flow, when it has to release the water flow. So depending on the instructions coming from the other controller, it will either close the valve or open the valve. So it is useful in the coffee machines and also the machines. And this is kind of vibrator. See, whenever your phone is in vibration mode, have you ever observed that whenever your phone is in vibration mode, whenever any message comes, your phone will be gets vibrated. How it gets vibrated? So this kind of vibrators are installed inside your mobile phone, so that whenever you put it in the vibration mode, whenever any message comes or whenever any phone comes, this vibrator will vibrate and it will give a output for you, vibration output. And this is very well known, that 7 segment display, and this is called OLED, organic LED. So it is a colorful display. You can display the images and you can display so many things over here. So like these are the different sensors and as well as actuators available. Okay, so just give me 1 minute gap over here, so that if anyone have any doubt about any other sensors, if anyone wants to know about any other sensor, so you can post your question over here. Even though you are not responded, and keep on asking the questions, because at least one question will give a happiness to me. So I will keep on asking the questions again and again. So if anyone is having any question regarding any sensors, if you want to know, or any application you have, if you want to know, you can post your question over here. So this is a little bit theory section, so you have to bear. So after this, we'll discuss about the protocols, and then we'll take some break of 10 minutes, and then we'll move on to the next protocols. It's very clear that up to now we have discussed about all the hardware controllers, what we can use, and we discussed about all the different sensors and actuators. And still, if you want to know about any particular sensors and all, you can post your questions over here. You can post it later also. Okay, so we'll do for the next topic. So the next topic here is hardware protocols. So let's go for the hardware protocols. So now, up to now, we have seen that what are the different controllers that we can have, like Raspberry Pi 4, Node MCU, Arduino, like ESP32, and Wi-Fi, like Uno plus Wi-Fi. Okay, we have Arduino, like Intel Edison, like we have ARM embedded, so something like that, different microcontrollers we have seen. And also we have seen about what are the different sensors available, like what are the different kinds of sensors available over here. So we have seen different types of sensors over here, and also as a part of output, we are also seeing few actuators also. Now it is time to connect these sensors to the microcontroller. So what are the different protocols that can be used to connect your sensors to the microcontroller? Those are called as a hardware protocols. So this is our next topic here, is hardware Now let's move on to that. The first protocol, there are totally four protocols generally used. Like one is I2C, I square C. We can call it also called as I square C or I2C. Okay, the people used to call I2C or I square C. Both are correct. Okay. And SPI is another sensor called SPI. Sorry, another protocol called SPI. And there is something called UART. And one more is nothing but one wire or linear linear buses. Okay. So these are the different protocols that we can connect the sensors with the Raspberry Pi. So these are the sensors, like this is the I2C sensor 1, sensor 2, sensor 3. All the sensors are connected through two different buses like SCL and SDA. Okay, these are connected to the Raspberry Pi. So something like that will be connected over here. So it is having only two lines of connection. Whereas coming to the SPI, we have four lines of connection, and the CS is extended CS1, CS2, CS3, like that. If you want to connect more number of sensors, you can even extend that CS4, and you can extend the device 4 over here. Like that, if you want to extend number of devices, you have to extend this connection. And there is something called UART, where we can call as a serial communication, that is TX and the RX. So why we have to use this TX and RX is that because serial communication is a very um, uh, it is having a little bit high speed, and as well as it is having a very traditional, like most of the devices are developed with the UART communication. So nowadays it is very accurate, okay, to be used, and also there are some uh, power issues are there in the UART. So like power, it will be very easy to handle the power in the UART. Okay. And there is something called local interconnect network, LIN or one wire protocol. So this one wire protocol, I will show one example for this also. So like that, these are the four different protocols we are going to discuss. The first one here is that key parameters are that what are the key parameters in I2C? Okay, one is number of devices and scalability, how many number of devices we can connect and how we can scale it, and what the number of connections, like one or two connections. See, here it is two connections, here it is four and five connections, here it is again two connections, and here is only one connection, single wire. It is a one wire, it is a single wire connection. So something like that, number of connections, and what is the reliability of the protocol, what is the timing of the protocol, what is the data rate, how speed it is, and what is the distance supported by the sensor. Like means few sensors may not support a long distance wires. For example, I have a big room. I want to install the different sensors at the different corners of the room. In that case, which protocol I have to use? Use I2C. I hope this is clear now. Kishan, are you there?
Yeah, Bharat, I'm here. Yeah, you
Yeah,
can continue.
yeah, thank you. Right.
Mhm.
So here, so we are continuing with this protocols here, I square C. So let me go to this. So here I square C. Yeah, this is the little details about the I2C here. This protocol is first introduced in 1982. So we'll see what are the I2C here. It is introduced in the 1982. Okay, it's a very lower speed devices. Like lower speed means compared to the SPI it is lower speed. But again compared to the other things it is not lower speed, it is a moderate speed. Okay, so its speeds are maximum it can support up to 3.2 megabits per second. Okay, in the fast mode, it will support up to first 1 megabit per second. Generally, we use this fast mode. This is the default mode that we use. Okay, and it will support the master and slave communication. Master slave means your controller, whatever the controller, Raspberry Pi, Arduino, or whatever it is. Generally, that master will be acts like a that controller will be acts like a master, and whatever sensor that you are connected, that sensor will be acts like a slave over here. And sensors are having different connections over here, different address over here. So we'll see all the basics by connecting one sensor here. So this is one two wires, that is SDA and SCL. This is SCL, so serial clock. SDA and SCL. So serial clock it is SCL. Okay. So SDA and SCL, these are the two. This is SCL. Okay, SDA and SCL, these are the two lines which are used in a I2C communication. For example, I have a 3-axis accelerometer. So this is a sensor which will works on based on the I2C environment. Like it is connecting to the I2C. Okay, so this is one example of whatever the things that you are going to use. Let me show you that how this 3-axis accelerometer will looks like. Okay, so this is the I2C sensor that how it will be work. So it will be worked based on the two wires, that is called the SDA and SCL. So based on these two lines, we will connect these lines to the microcontroller. So the microcontroller may be act like a master. So this is your master, like you can take it as a microcontroller, the Raspberry Pi or whatever it is. Okay. So let me show you that 3-axis accelerometer which worked on the work based on the I2C connection. So let me close this. Let me open a browser here. Let me open Google, and let me show you a 3-axis. Like you can call it as a ADXL 345. So you can call it as ADXL 345. So this is a sensor. You can see here. This is the sensor which will work on the based on the SDA and SCL. So here you can see this picture. Here we have last two lines. One is SDA and one is SCL. That means the last two lines, if you are connecting to the microcontroller, the last two lines will use the I2C communication. That means what is actually this accelerometer will do? It will measure the XYZ parameters of a particular device. For example, if you are assigned this, if you are attached this sensor to a particular vehicle, otherwise if you are attached this sensor to a particular device, so whenever this device get turned, it automatically it will show the change in the measurement, like change in the x-axis, change in the y-axis, change in the z-axis. Like that, it will find out the position of a particular device. Okay, so how it is communicating with the sensor? It is communicating with the sensor with the SDA and the SCL parameters. So this is your sensor. So how will you connect these to Raspberry Pi? Here is I will show you that LXC Raspberry Pi. So here, this is the connection over here. If you are able to, I will take a little bit this one. Okay, so here, yeah, you can a little bit smaller for me. I'm very sorry for the wrong selection. And this is a little bit clear here. So see, SDA is connected to the pin number 1, 2, 3 here. This is the pin number 3 here, and SCL is connected to pin number 5. So why we have to connect pin number 3 and 5? See here, pin number 3 is a, see this is the pin number 3 is a SDA, pin number 5 is a SCL in the Raspberry Pi. That means we are connecting the SDA pin to the SDA pin of Raspberry Pi, SCL pin of the sensor to the SCL pin of the Raspberry Pi. So here we are doing simple connection through lines. One is SDA and one is SCL. So this is a smart communication. How we are doing with the I2C. Okay. So let's see the output for this. So here I have connected my sensor to the Raspberry Pi here. So let me open my Raspberry Pi here. Raspberry. Okay. And when I press OK. So this is the program. So where I'm importing one library for ADXL 34X. Okay, to communicate with I2C, I have to import this library here. Not communicate with I2C, communicate with the ADXL. So what is this ADXL? Three-axis accelerometer. How we are connecting? We are connecting through I2C connection. So that is very important for us here. Different sensors are having different connections. Yesterday we have seen that uh, ultrasonic sensor, how it is connecting? It is connected to GPIO pins. But whereas this three-axis accelerometer is connected to the I2C pin. So let's execute this. It is giving the axis. This is our x-axis value. Okay, these are the y-axis value and these are the z-axis value. So let me move the sensor here. So depending on the moving, see I'm moving the sensor in a different directions. So depending on the moving, so values of x-axis, value of y-axis and value of z-axis are changing here. So like that, whenever the device is moved in the different directions, the value of x and y and z, these things are going to be used. You can ask that, so where we can use this sensor? We can use in an accident alert system. So whenever you have a three-axis accelerometer in your car, and whenever I'm very sorry to say this, but whenever people will meet with an accident, the car position will be changed over there. So that what happen here will be immediately give some alert that okay, so the position has been changed. So something happened over here. So something like that it will give us some alert message to the known people or to the police people or whatever it is. And second one is that elder people are there. Generally, they used to fall down on the ground. So whenever you attach this kind of sensor to the hand part of that particular people, so when they are fell down and when they are fall down, depending on the x-axis and y-axis measurements, we can easily find out that the people has fell down or something like that. So something like that. This three-axis accelerometer is having so many other applications in the mechanical industries and in the automobile industries. In automobile industries also, this is having so many other applications. So like here, my intention is to give you that how to connect this to the uh, I2C, I2C communication of your Raspberry Pi. So let's close this. Okay, let me open the browser here. Let me open the camera over here. I want to show you the sensor, how I connected the sensor over here. So just I want to show the sensor over here and then I will go for the other things. Like here is one, two, two, seven, and then eight, and then six. And you can see here, uh, this is my accelerometer sensor. This is you can see that the last two connections are SCA and SDA and SCL. The last two are SDA and SCL, and the first are VCC and ground. So I connected this SCA and SDL and VCC and ground to the this particular Raspberry Pi. So here connected all the connections over here. This is your SDA and SCL pins of Raspberry Pi, and these are my this is my sensor over here. So this is one of the I2C sensor that I connected over here. I'm very sorry that the picture is not clear. Okay, anyhow, so this is a sensor that I have connected for I2C connection. So let's close this. Okay, next we'll go for the uh, SPI sensors. But before going to that, I want to take a. So we have seen I2C protocol, and we have seen one example of I2C protocol how to connect to the, any controller. So whenever you working with any controller, you have to observe these two pins like SDA and SCL pins, where these SDA and SCL pins are available. So according to that, you have to connect your sensor to that SDA and SCL pins, and you will do the I2C communication between the sensor and the microcontroller. Here, sensor will act like a slave, and your controller will act like a master. And also we are saying that it is having unique address. So let me show you the address of this particular sensor. So how to no, no, no. I didn't share my screen here. So, yeah, let me share my screen and I will show you. Okay. Yeah. Now I think you are able to see my screen over here. So let me open the my Raspberry Pi over here. So this is my Raspberry Pi. I think you are able to see my screen now.
Yes, sir. Your screen is visible, sir.
Yeah. So I'm just entering into my Raspberry Pi once again here, and I want to show what is the address of this sensor because I earlier told that I2C is having every sensor, every slave. So here slave means sensor itself. So every slave is having a specific address. So let me show you that address here. So for that particular purpose, let me close this, and we have to type one command over here to know the address of the sensor what I have connected to the I2C. So sudo I2C detect hyphen y space 1. So if you are able to see this, this is the 53. 53 is the hexadecimal address of this particular 3-axis accelerometer. So similarly, if we connect a body temperature, you will get a address called 5E. So something like that for different sensors. Like you can use a pressure sensor. Like if you are able to see this, there is some sensor called BMP 180. So this BMP 180 is also I2C sensor which will measure the pressure in the air, temperature, humidity, and pressure and altitude of a particular place. For example, whenever you are climbing the hill stations, so we should not climb more heights. We have to always measure that what is the air pressure at this particular height and what is the altitude at what altitude we are presently in. So something like that altitude and pressure will be measured. So for that particular purpose, we use the BMP 180. So that is also I2C. So something like that. There are different I2C sensors are available. So depending on your situation, you have to choose one of the I2C sensor and you have to connect here and you have to know the address of the sensor. So this is I2C sensor. So let's move on to the next protocol, SPI protocol. So this is what. Okay, let's move on to the UART protocol. So UART protocol means generally you know that TX and RX. So whenever we have a two things like transmitter and receiver. So whenever you have two things like TX pin and RX pin. So if any sensor is having TX pin and RX pin, then that is called as a UART sensor. So what are the examples of this UART sensor is that one of the very majorly used UART sensor is GPS sensor. So you might have heard about very well about the GPS. What GPS will do? It will measure the position of a particular place, like longitude and latitude of a particular place. So generally, why we have to use this GPS? If you install this GPS in your device, we can track your device, where your device is moving. So every 2 minutes, if you try to read the GPS location, so it will track and it will tells you that the vehicle is moving in this direction. The vehicle is moving in this particular location. So I think we were in so many uh, films you might have seen that we are tracking the GPS location of the mobile, so that the mobile is moving in some location, so that we can understand that the particular vehicle is moving in this direction. So something like that we can use the GPS is one of the majorly used UART protocol. Similarly, there is one more majorly used protocol, sensor is there that is called GSM. So GSM is a one more major UART protocol. So it will work on the TX and RX pin. So it also works on the TX and the RX pin. So of course, these two are asynchronous transmission. Like there is no like the whatever the data that is transmitted in the form of baud rates. You might have know about that. What is the baud rate? Meaning of baud rate? It is 9600 symbols per second. or sometimes we can use 11.00 bars per second, like symbols per second. So these are the different baud rates. That means number of bits, sorry, not bits, number of symbols per second. How many symbols are uh, transmitted may. Again, you may have a question what's the difference between symbols and bits. Sometimes one symbol may have multiple bits. Okay, sometimes one symbol may have multiple bits depending on the NRZ, RZ, some data schemes are there. So depending on the data schemes, one symbol may have multiple bits. So we can't say baud rate means it's not like bits per second, it's a symbols per second. Okay, so something like that. There is something called baud rate is available for the all these things. And coming to the sensors, so there are two pins majorly available in this RS-232. One is called TX transmitter pin, and one is called RX receiver pin. Okay, so using this will do the communication and all these things. Okay, so presently I have the GPS sensor, but I can't show the output for you. But I can show the how the GPS will be looks like. So let me close this and let me show you how GPS is looks like and how to connect this to the Raspberry Pi. Okay, so let's minimize this. Let's make it here and let me open the camera over here. Let me open the camera. Okay, so let me start this. So here you are able to see that this is your GPS sensor. So this is the antenna, GPS antenna. So that this antenna is going to be uh, sense the location of your particular device. So if you are generally, if it will not work in the indoor locations, generally you have to be measure the location outside the uh, buildings. So you should be on the road, or otherwise you should be on the open place. For example, if you are measuring it in the university, so you should have to measure in the open places, not in the closed places. If you try to measure the closed places, you will not able to receive any location or any position. Okay, so don't compare this with the mobile GPS. Mobile GPS is very accurate, and that will be worked on the internet. Okay, and this is uh, sorry, no, mobile GPS is not worked on the internet, but it is going to be worked on the different number of satellites. It is worked on the core number of satellites here. Okay, so that's why it will not work in the indoor places. It will work only in the outdoor places. Okay, and see if you are able to see. I think I don't know whether you are able to read or not. VCC, RX and TX. Okay, you are able to see here RX and TX. So this RX and TX are your UART communication. So we are connecting this RX and TX of your uh, sensor to the Raspberry Pi RX and TX. Okay, so that is the way how we can connect this UART communication. So like that, see, there are different protocols available. So many people don't know that they are simply connecting the sensors, but they don't know about what kind of sensor it is. Whether it is a URT sensor, whether it is a I2C sensor, whether it is a SPI sensor, whatever it is, they don't know about all those things. But simply will try to work on it. But so don't go blindly. So at least know about what sensor you are working on. So this is I2C. So let me move on to the next immediately. So next we'll move on to the next one immediately, like SPI. So the next protocol here is the SPI protocol. So let me show one example on the SPI protocol here. Okay. So first of all, what is SPI here? So SPI is a serial peripheral interface. This is very high speed devices. So whenever you have a very you want to transfer the data very quickly, or you want to transfer the data in a high speed manner, then you can use the SPI sensors here. So compared to the I2C, SPI is a little bit high speed. Okay, so if you clearly observe that, how many of you know about the RFID tags? Like your tags, whatever the RFID tags, whenever you are like your debit cards. So nowadays the debit cards are coming with some Wi-Fi RFID that is called as NFC, near frequency communication. So that particular sensors are communicating with the SPI protocol only. Of course, communication will be done on the wireless, but this sensor has to be connected to the some controller. Internally, it has to be connected to some controller. So internally, it is connect. It is going to use the SPI protocol over here. Okay. So in this SPI protocol, we have these are the pins that we have C, CL, SDI, something like that. Of course, we are also have a different notation here. So this S clock, this is the serial clock here, and this is generally called as a serial data input. So that is called as a MISO, master input, okay, master input, slave output. So this is other terminology. Some sensors will have a terminology like MISO and MOSI, and some sensors will have the terminology like SD and SC. SDO and SDI. Please observe that clearly here. I'm writing here MISO, MOSI. These are the alternative things like MISO is same as SDI and MOSI is same as SDA. Okay? Some sensors will give a notation like this SDI and SDO, and some sensors will give a notation like MISO and MOSI. Okay? So in this way, these again, if you see this, the last one is save select. So each and every save select is connected to the one of the GPIO pin of your controller. So this is your GPIO pin of controller, GPIO pin. See, second sensor is connected to other GPIO pin of the controller, third sensor is connected to other GPIO pin of the controller. But these three are common for all. See, for all the three sensors, these three pins are common. And the fourth pin is going to be vary for individual sensors will have individual GPIO pin. So that is a recognition here. In the last sensor, I2C is recognized by the unique address, but SPI is not recognized by the unique address. It will be recognized by the individual GPIO line. You have to observe very clearly that how a slave is recognized here. Slave recognition is very, very important for us. In the I2C, slave is recognized by the unique address. Last time I showed you that 3-axis accelerometer is having a unique address called 53. Similarly, BNP 180 is having a unique address called 772. So something like that. Different sensors will have different unique addresses. Okay, so these different sensors will have different unique addresses. Similarly, here in the SPI protocol, different sensors will have different GPIO pin. There is no unique address available for this particular thing. So whenever you want to connect SPI sensor, you have to connect this fourth pin of the sensor to the different. This is also called as CS, chip select. I think you people very well know CSC people are very well known about this CS. I don't know which background you are from. I'm very sorry. I don't know which background you are from, but this is chip select. The CS people will know. The computer science background people will know very well about CS, chip select. Okay. So this is going to be used for connecting to these different parts of your master. Master is always microcontroller. You remember that master means microcontroller. Slaves means sensors in our case, especially when you are discussing about the IoT, all the sensors are slaves and all the controllers are masters. Okay, so let me show you one example over here before going to that particular thing. Let me show you one more example here. Have you heard about the RFID sensor? How many of you have heard about the RFID sensor? So this is your RFID sensor. Yeah, this is your RFID sensor. So this is generally used to this card is given to the client so that whenever generally in the attendance system we use this RFID. Okay, in the attendance system generally we use this RFID cards. So this RFID card is connected to the SPI connection. Why I'm showing this example here is that so these are the four connections are related to the SPI protocol. So we are connecting this SPI pins. These four are called SPI pins. So these SPI pins are connected to the power pins. There are power. There is a power here, but these SPI pins are connected to the SPI pins of your sensor. So this RFID is one of the best example of SPI protocol. And also there is one more example here. As you said that Raspberry Pi doesn't have the analog pins. So whenever you want to connect the analog pin, you have to connect a external ADC chip. Last time we discussed that external ADC chip is required. So why I'm discussing here now that this ADC chip will use the SPI connection again. Whatever the MCP3008, whatever the ADC chip that we are using here, that will also uses the SPI connection. So there are two examples of SPI. One is MCP3008, which is a ADC chip, and one is RFID reader, which is a SPI connection. Okay, so let me show you the program for this. See, why I'm showing you all these things means just I want to make sure that you people have to know how many different types of sensors are available outside, and how they are connected, and how to get the values from those particular places and all these things. So this is my intention of showing all these things. Okay. So let me open that RFID program, RFID read. See, if you observe the programs, there are very few lines. Like earlier we observed the program, that is very few lines. Now here also very few lines. Like that, the body temperature sensor. See, only 5 lines are there here. But what happened here? The program, complete program, will lies in the library. So you have to know whenever you want to use any sensor, you have to know which library you have to install. So you can ask the question, sir, how to know that one? Again, it will comes from the experience. Like whenever you want to use one particular sensor, you can search. You can search it in the Google sheet. Otherwise, sorry, data sheets of the particular sensor, and you can because there are so many open sources are available for you. So you have to get it in the forums, and you have to search for that, and you have to get the library names and installation process and all this. But here there is a one simple library, the simple MFRC 522. I think yesterday you have seen how to install the libraries. Yesterday already you have seen that how to install the libraries and all. Okay, how to install the libraries. So yesterday we have seen that we have to open the command prompt over here, and we have to type sudo pip3 install pip3 install uh, what is that? Install simple like MFRC 520. So something like that, we have to type this and we have to press enter. So that this particular library will be installed over here. So something like that, we can do installation very simply, and we can write a small, a few lines of code, very few lines of code, and we'll get the connection. We will do the connection over there, and we'll get the output. So here, just give me some time. So I'm connecting my uh, what is this RFID sensor over here. I'm just connecting. I'm trying to connect the RFID sensor over here. So give me a 1 minute time. I will connect my RFID sensor over here, and I will show you the video that how I connected here. Okay, so okay, so um, just a minute. Where is my card? So this is the program, very simple program. But before executing this program, so let me minimize this. Let me minimize this and show the video that how I connected the sensor, and then we'll go for the this one. Okay, I'm giving an error over here. So let me start the server. Okay, your headset. So let me show you that. So this is my RFID card, RFID reader here. It is I connected this one, and I don't know if you are able to see. Very difficult to show you the connection over here. No, no. I don't know. We are able to see this very blurry. I think there are it's not visible. Like there are connections are like MISO, MOSI, VCC, ground. There are connections are there, and I've connected these wires over here. These wires and all these things are connected over here to the Raspberry Pi. Okay, this is my RFID reader, and this is my card. So this card is available in the form of keychain here. So this is available in the form of keychain here. This is my reader. So whenever I keep this reader here in front of the RFID reader, it will read the input over here. Okay, so that's it. So let me show you the output over here. So let me open the Raspberry Pi here and let me execute this program. So when I'm running this program, yeah, it is now I think it is ready to read the output. So see, whenever I placed this, it is reading the 007. This is my ID and this is my name, BHARATH Kumar Allam. So this is my name. So it is reading from the reader. So something like that, it will read your ID and your name and all the details, whatever details it is there, and you can handle those details inside the Raspberry Pi, and also we can write some other logic, like once it is detected, what it has to say, like valid detect, valid person, invalid person, something like that. You can write your code extension here. But here I simply printing the ID and the text. ID is 00, no, not 007. ID is the different one. Text is the 007 Bharat Kumar. So like that, each and every card will have some unique ID, and we can write some text inside the card. So for writing the text, I can use one more other program like here. The other program for writing, see this is RFID write. So if you want to write your own information, here if you want to write your own information, you can open the program like this, and if you run this, okay, so then it will asks you for that. See, you have to enter the new data. So let me enter the new data here. I want to enter my colleague's name, Kishan Mohan, with the ID of 006. Okay. So just I want to enter this ID and I press enter. Now place your tag to write. Now I'm placing my tag here. Data is written inside the card. So when this data is written inside the card, so let me execute the read program once again so that we'll see whether it is reading the new data or not. So let's go for RFID read. This is here RFID read. Let's run this. Okay, and let's see this. See now, earlier I got 007 Bharat Kumar Allam, now I'm getting Krishan Mohan 006. I updated the data inside the card. So something like that, we can use RFID card we using the SPI connection. So like that, we have different connections, and we can use all these connections to connect different particular places. Okay, um, like right. So these are the different details about the hardware protocols. Similarly, let's move on to the next protocols over here. So let me close this. Let me close this and move back to the PPT here. And let me move on to the next. So already we have seen that GPIO. Yesterday we have seen that LDR sensor, that like your DHT11, and also URT sensor. So these are all GPIO sensors. So no need to give much information about this GPIO. So this GPIO will have a same like fingerprints. Okay. And the protocols and standards. So we are seeing that here this Bluetooth is there, Zigbee is there, Wi-Fi, Internet, and this last area. This is the area where we can have hardware protocols. This is the place where we can have the microprocessor unit, and WAN. So this is the place where we have discussed what are the things that we discussed, I2C, SPI, and all these things. In the next level, we are having a Bluetooth, Zigbee, Wi-Fi, Ethernet. These are all second level. And third level is the networking protocol. I said gateway. So this is your gateway. This is your sensors and microcontrollers, and these are your wireless protocols. And for gateway, we have 6 LoWPAN and IP version 4 and version 6, like IP addresses. How we are connecting the device through gateway? So using some IP address. So using some IP address only, we can connect the devices to the gateway and all these things. And after that, we have application protocols like HTTP, OAP, MQTT. These are all the application protocols we have. So to connect to the cloud here. So this will comes in the cloud, and these will comes under the applications or products. These are all some open source protocols. These are all uh, not the generally used. This is very rarely used protocols like OCF, IPSO. These are all some OMA, OMA, OCF. These are all the different open source protocols which is used by the very few people right now, because these are emerging technologies. So few are already established, like OSF is established, IPSO is established, but of course these are very less number of devices are using these IPSO and the OSF and all these things. But these are all open source protocols. Like that, there are different levels of protocols in a different way. I don't want to discuss about this OSF structure right now. So let me move on to other one. So let me stop the screen for a few minutes. Let me give 1 minute time. So I will stop sharing for a few seconds, and I will come back. So let me come back to the another protocols. Yeah, let me share the screen here. Let me share the screen once again. I hope you are able to see right now. Yeah, I think you are able to see the screen now. Okay. So next we are going to discuss about a few things called wireless protocols. Okay, right. So these are the wireless protocols that we have: Wi-Fi, Bluetooth, Zigbee, LoRa, LTE, and SIGFOX. So let's have a quick look at this particular wireless protocols, and also I will show you which are the devices available with me. I have a few devices which are available with me. I will show you those devices along with the. I will discuss about a few features of these particular protocols. And always you can remember that whenever you are going to the practical case, where we use these wireless protocols. I am again and again I'm saying that there are particular situations where internet is not possible, but you want to transmit the data for few distance. Like sometimes it may be few meters, sometimes it may be a few kilometers. How you will transfer the data few kilometers without having internet? See, for example, there are something like there is no mobile signal available, there is no Wi-Fi is available, there is no broadband is available. But I want some hill stations, otherwise some remote locations where nothing is available. But I want to collect the data of that particular remote location, and I want to transfer that to a location where everything is available. Means from that particular remote location to the location where everything is available, we can transmit this data using the wireless protocols. So this is the way we'll use the wireless protocols. Let's see, the first one here is Let's see the first one here is that uh, Wi-Fi. Okay, Wi-Fi is a very well known. I think you people are very well known about the this Wi-Fi protocols over here. Okay, so this I don't have much discussions over the Wi-Fi here, but what is the advantage of this Wi-Fi is having? Uh, it is having high speed, very high speed device it is. So like if you want to achieve the 54 Mbps, and otherwise sometimes it is in a gigabits also, you can achieve through this particular Wi-Fi. But what is the disadvantage of this Wi-Fi is that this Wi-Fi doesn't transmit much distance. So the distance that message transmitted over here is very less. Okay, but you have to observe very clearly that the distance is very less for the Wi-Fi. I will not discuss much things, but I want to give important features of this particular uh, things. Okay? So I know that most of the people might have heard about the 2.4 gigahertz and 5 gigahertz. There is something 2.4 gigahertz and 5 gigahertz. So these are the called as unlicensed bands. So these bands are going to be give some information about the 2.4 gigahertz and 5 gigahertz. So nowadays 5G Wi-Fi is coming. That 5G means it's not like 5G technology. It's a 5 gigahertz frequency that you have to understand very clearly that there are some 5G routers are available and 5G few things are available 5G. So few things are available 5G means not it doesn't mean that it's a 5G technology. It's a 5G frequency, 5 gigahertz frequency, so which is having some good advantage of higher speed and as well as a little longer distance compared to the 2.4 gigahertz. 5 gigahertz is having a penetration is more. Like for example, 5G. For example, if you are having a router inside your home, so you are getting so many signals. So if you are using a 2.4 gigahertz, you will not get into the other room. So like other room, you will get very weak signal. But whereas it is 5 gigahertz, you will get the signal very strong signal in the other room. So like that, the penetration of the signal is very high in the 5 gigahertz. So that is the one advantage over the Wi-Fi. But always remember that Wi-Fi is not meant for the long distances. Okay. The next one is Bluetooth. It is established in 1994, and again it will work on the same frequency like 2.4 gigahertz. But nowadays the Bluetooths are available in a almost it is available up to 100 meters, like from here to some other place. Like it will be a different place, like 100 meters, more than almost 100 meters, not more than 100 meters, but most probably it will available up to 100 meters. The present version of the Bluetooth is 5.0. Actually, by this time we have only 4.2 version, but present version of the Bluetooth is 5.0. Okay, and this is going to be uh, Zigbee. The next one is Zigbee. But Zigbee is again a tough fighter for the Bluetooth because Zigbee is having very accurate information transmission. So like Zigbee is one. Actually, what happened here in the early stage of the Zigbee invention, Zigbee will support what we can call mesh connection. It will support the mesh connection. I think you might have heard about the mesh connection here. So what is the mesh connection over here? So here to here, here to here, here to here, like any device to any device, it can able to do the transmission. That is what called as mesh connection. So there is no transmitter receiver. Every device will act like a transmitter and acts like a receiver. Means it can able to send the information and as well as it can able to receive the information. So it's like a complete mesh connection is available within the devices. That is one of the big advantage earlier. But nowadays, Bluetooth is also supporting the mesh devices, mesh connections. But earlier Bluetooth is not supporting the mesh connections. But now Bluetooth 4.2 and the Bluetooth 5.0. These both versions are now supporting the mesh connection. So now Zigbee is facing the problem. Like, of course, there are so many devices which are already existing in Zigbee. But the advantage of the Zigbee is that still the Zigbee is very uh, like the dropping of packets is very less in the Zigbee. So it will be very secure and also it will send the packets very securely, like without dropping a pin, a point, a small information also not dropped by the ZigBee. So that is the big advantage of ZigBee devices. Okay, and last but not the least is LoRa. LoRa is a long range devices. Like whenever you want to transmit more than 1 kilometer, like it support up to 10 kilometers of device, like information exchange. So this is what I said. So whenever you are in remote location and you want to collect that data and without any internet connection, without any connections, you want to receive that data to the place where internet is available. So then what happens here? We have to keep one or two LoRa devices over there, so that this LoRa devices will transfer the information from the 5 kilometers to 10 kilometers. Okay. So like that, if you're using two or three LoRa devices, you will get remote location information without any internet connection. So that is the one big advantage of the LoRa. Okay, there is a one more something called the competitor of the LoRa is a SIGFOX. So this device is a complete competitor of the LoRa devices. Okay, so but what happened here? The SIGFOX will depends on the small towers. It's like cell phone towers, not bigger one, not very big towers like cell phone towers. Cell phone towers are very high. It means very high. Uh, Height is very high for the cell phone towers, but these are the SIGFOX towers are very short towers. It's not like the bigger one, but it requires a tower to transmit the information from one place to other place. Again, the SIGFOX is also used 10 kilometers of range. Okay, but of course, presently SIGFOX is not used in India. India, the people are not having any SIGFOX till now, but it is used in the European countries. All the European countries are almost they are using the SIGFOX network instead of LoRa networks. So these are all just now we have seen that narrowband IoT like LTE. LTE means your 4G or 5G. So 4G technology is LTE, and after that we will get the 5G technology also. So of course 5G is presently it is about to launch. It's not launched at all. Um, NB-IoT. NB-IoT is also again narrowband IoT. Narrowband IoT means your NFC. Just now we discussed that RFID card. So those kind of small bandwidth frequencies, those when it comes under the NB-IoT. So like that, there are different wireless protocols available over here. So these are the different things which are available in the wireless protocols. So what is my conclusion over here? So before going to the application protocols, we'll see the application protocol in the afternoon session. We'll continue this in the afternoon session, and we'll see the cloud also. We'll see the one cloud called ThinkSpeak, and if time permits, we'll see the other clouds also. But if time permits only. Otherwise, we will go through the one cloud completely from end to end. Okay. But before going to that, I want to conclude these wireless protocols. So inside the wireless protocols, the first one is Wi-Fi. This is very popularly used. But what is the disadvantage of Wi-Fi is that it will use a more power, so which is not suitable for IoT applications. It is not going to be work on the it is not going to work on the battery power because it requires more power. So in such situations, we will get things like small applications. For small applications, we should not use the Wi-Fi. We can use the Bluetooth. So Bluetooth and Zigbee, these are the very low power wireless devices. And the Bluetooth and Zigbee almost having all the same features right now because Bluetooth and Zigbee both are competing each other. So both are providing good facilities for end user. For the client, they are providing the good facilities. Whereas only thing is that if you want to go for a very accurate information, if you don't want to lose any small information also, then you have to go for the Zigbee. But a little bit okay. So it's not like that much critical means then you can use it for the Bluetooth. Why? Because Bluetooth installation is very easy compared to the Zigbee installation. So whenever you buy any Zigbee device, installation of the Zigbee device is very not that much difficult, but it is complex compared to the Bluetooth installation. So Bluetooth devices are very simply installed without any very having a high difficulty. So that is the only advantage of Bluetooth over the Zigbee. Otherwise, both are same. Almost both are going to be same. And coming to the LoRa and SIG parts, these are two long-range Wi-Fi devices. See, whereas your Bluetooth and Zigbee will support up to 100 meters only, not support up to kilometers. We support only 100 meters. That is within a building, one floor to other floor. If you want to transmit the information, then we can use the simple Bluetooth devices. But whenever you want to transmit outside, and if you want to transmit from remote location to the other location, then you have to use the either LoRa or SIG parts. Again, LoRa is supported by the India, so we can use the LoRa without any difficulties. But Sigfox is not presently not available in India. Okay, so we can use LoRa for long range communication. So these are different, like for short range communication, like RFID cards and like your tags, like whatever the barcode readers and all these things. These are all comes under the NB-IoT. It's a narrowband IoT ecosystems. So these are all comes under the small applications which will use this particular NB IoT applications. So other than this, we have 4G and 5G technology. This is called LTE or 4G technology or 5G technology. So GPS, GSM. You can call it as GPS and GSM. So that will come under the different category. Okay. So these are the in short, these are the different wireless uh, technologies that we are having. Okay. So with this, I want to stop my morning session over here. Okay. And if you have any questions, please raise your questions over here. And we'll continue in the afternoon session with application protocols and as well as cloud. Okay. I think my side it is very clear.